already? Okay, then give me 2 minutes. Here. Okay, yeah, thanks. So good afternoon, everyone. This is Dr. Niket Kaisare from the Department of Chemical Engineering, IIT-Madras, and I've been the course instructor for MATLAB programming for numerical computations course. So we are going to have answers to some of your questions that you have posted online to try to answer some of your queries that you may have had. So we already have one question that has come in the live chat. So if you have any questions, please do ask in the live chat. What I will do before I answer the question in the live chat is go over some of the questions that you have already asked through the Google Documents link that was provided earlier. So let's go over some of the questions that was there. So I've got categorized your questions into different types of questions. And the first set of questions actually were regarding the final exam itself. So the questions that had come were how to solve the final exam without MATLAB. This is a course that we have run one time earlier as well, and we have had this question asked multiple times, is if you do not have an access to MATLAB, then how do we answer the questions that that will be posed in the exam? So also the another question was that I posted the pattern of the final question paper, but people wanted to know a little bit more about the model paper itself. So let's go over the final question paper pattern, and this will probably answer your questions regarding the how to solve the questions when you do not have access to MATLAB. Okay. So questions, and there will be 5 questions of this type. Recall your MATLAB commands, 1 point for each correct answer. And again, this is going to be 1 point gives you an indication of what we expect from this question. We expect something very straightforward. There's no trick or anything involved in this question. Just an example is find the eigenvalues of a square matrix. So let's say the matrix is A and you want to find the eigenvalues of A. The way you will do that in MATLAB is using the command EIG. So all you have to do is in the space that is provided to you, type EIG, and that's all. Do not include additional spaces. Do not include EIG under in brackets A and so on. Just the name of that command, EIG for eigenvalues, TRAPZ for trapezoidal method, FSOLVE for solving nonlinear equations, etc., etc. So those are the various functions that you have used in your 8 modules so far, and in the remaining 2 modules you will be using them. So this is a direct question from the commands that you have used in those modules. How to review the material, for example. The first thing that I would usually recommend my students do is review the assignment problems, because a lot of these questions are based on the assignment problems as well. So review the assignment problems, review the notes that we have uploaded. So various notes, for example, let's go on to differentiation. So these are the notes that we have uploaded on numerical differentiation. So this is one way to, for example, review that. So just to take an example, forward difference, central difference, backward difference formula. These are the three different formulae, and forward difference and backward difference are order h to the power 1 accurate. Central difference formula is order h squared accurate. This is how the formula looks like. You are not expected to remember the formula. So that we are not expecting, but you are expected to remember, for example, what are the commands that we use in MATLAB. So for example, to get tan inverse, the command that we use is atan, which stands for rtan. If you remember, we have used that command in the first module itself. So in the assignment for the first module. So by reviewing that, if you have done the assignments very carefully, you would remember a fair bit of it. And by reviewing the assignments and reviewing the notes that are posted, you will be able to review a lot of the things that are required for the exam. To do a complete and thorough review, you would have to refer to the notes that you have made as well as the video lectures also. So all of the questions are based on that. So we have talked about the first set of questions. Let's go to the second set of questions. And the second set of questions are multiple choice questions. So you need to be a little bit careful with respect to multiple choice questions because there is a negative marking for multiple choice questions. 2 points for the correct answer, -1 for the wrong answer. So let's look at the multiple choice question that we have over here. Okay, which of the following is true for central difference formula? The first is it yields exact solution without an error. Obviously, this is not correct. We have seen how the error changes with the step size. So that means that there is, with any numerical method, some kind of an error associated with that numerical method. So this is not true for central difference formula. Error in solution depends on function f and not on step size. My previous statements again shows that this is not true. It's usually more accurate than the forward difference formula. That looks like that would be the correct answer. Let's look at it's usually less accurate than forward difference. That's again not true. So C is the correct answer. So it's an MCQ. Only one correct answer is expected. So just mark that correct answer. If you think there are two correct answers, mark the one that you think is the better out of the two. So it is, we have formulated the question so that there's only a single. There is a single correct answer. Okay. So as just to repeat what I said, we have 5 questions of the first type, which is to recall your MATLAB commands. There will be 7 questions of the multiple choice type. So MCQs are 7 in number. They are on things that you have seen in the video lectures and or the assignments. So they kind of test your fundamentals on that you learned while going through this particular course. So there are 7 of these types. The third type of problems are match the columns. So in match the columns, the problem that you want to solve is on to the left hand side, and the command that you can use to solve it is on the right hand side. Okay, there are 5 match the following questions. There will be 5 questions on the left hand side, and I believe there will be 8 answers on to the right hand side. So of course there's not a one-to-one mapping, but there will be so for example, solving linear equations, linear solve, this is kind of a trick question for you. So linear solve, if you remember, we have never used a command called linear solve at all. So linear solve is not the correct answer. COND, con is for condition number, INV is for inverse, and so on and so forth. So probably, if you remember, if you have AX equal to B, then we can use X equal to inverse A multiplied by B. So INV is the most appropriate choice. So the correct answer in this case will be C. So you'll have to mark C. Another example, if we want to approximate e to the power x using Maclaurin series, none of the above A, B, C, D, E, F, G will not be true. The only correct answer will be H, that is none of the above. So you'll have to select H. Okay. So this is what you will have to do. So it will be kind of, it will show up like an MCQ type of a question itself. where each of the 5 questions related to the match the columns on the left hand column will appear as an independent question, and you have to choose between A to H as the correct answer. Each correct answer gets you 1 point, and there are no negative markings. Please, you can get the correct answer in order to get full points for this. So this is the match the columns, and if you see, the match the columns has 2 points per question, whereas identifying the command name had 1 point. Again, this type of a question and match the following questions are not very different from each other. What happens in match the following questions is when you have the left hand side with 5 questions and the right hand side with 8 answers. Sometimes we have seen data in 5 different courses in the past. Students do tend to get confused, and therefore we give a greater weightage in match the following questions. Okay, and there are a few more questions that are coming up. Yes, I will answer to those questions also. Next one is objective type questions, and there were 2 type of questions that you guys had asked regarding the objective type questions. The first question was, will we be allowed to use calculators? So yes, in your exams, please bring your calculators. Your regular scientific calculators are what are allowed. Non-programmable calculators, the one that you use in your colleges, you can bring them for this exam, and you will be allowed to use them. Just an example over here, cum sum is cumulative sum. So cum sum of 1 to 10 will result in a vector of size 10. The first element is 1, second element is 1 plus 2, that is 3, third element is 1 plus 2 plus 3, that is 6, fourth element is 10, so on and so forth up to the final element. So what the size of the vector? The size of the vector will be 10, so therefore the answer over here will be 10. Fifth element of the vector is 1 plus 2 plus 3 plus 4 plus 5, that is equal to 15. So over here, please enter the value 10. Over here, please enter the value 15. The objective numerical type, it will be a numerical answer. We are expecting a numerical answer only. There will be 8 questions of this type. Each question, I believe, is worth 2 points in the objective numerical type, and this is where you will require a calculator. And again, the questions are going to be reasonably straightforward. There might be one minor MATLAB funda that is involved in addition to the command itself that will help you in order to solve this problem. The next question is to write a single line MATLAB code. The single line MATLAB code example that I've given over here is write a MATLAB code for computing factorial of a number n. So given a number n, how do we compute factorial? We had gone over that in the first module. To compute the factorial, you can use the command prod. The command prod will multiply all the elements. So if you give fact val equal to prod 1 colon n, that will be the correct answer. Please don't include excess spaces in this. You just give the result as shown over here, so that you get graded appropriately. Loops are not allowed in this particular type of problem. The single line MATLAB code problems, please do not use for while loops. The problems are such that you won't require if-then statements. So this is the type of questions of MATLAB codes, and there will be 5 questions of this type. So you have to answer these 5 questions in the single line MATLAB code type of problems. Thereafter, we will have spot the error problem, and there will be 3 problems of this type. And here, what you will be required to do is, I'll give you a screenshot of a MATLAB code. This will be a reasonably small MATLAB code, 10 lines or lesser, and you are expected to spot if there is any syntax error in that MATLAB code. So if there is an error, you need to point out which line that error is. So in this case, for example, x is a vector, so you cannot square a vector. You can only do an element by element squaring. So this line will have an error. So the error is indicated on line number 2. So the correct answer for this is line number 2. So 2 would be the correct answer.
Another type of problems for spot the error would be how do you correct this particular line, and in this case the correct code is going to be y equal to x dot caret 2. Okay, so this is how you will solve the spot the error type of problems. Again, you do not really need MATLAB for this, but it will test your MATLAB skills to a slightly higher level. So I believe, based on my experience in the past, spot the error type of problems are probably the trickiest problems in this entire exam. There are 3 problems, each worth 5 points, so 15 points worth of these 3 problems. They might be slightly trickier. I would suggest give yourself some amount of time to think about these problems. Keep in mind there are no negative marks for spot the error, so please don't leave this answer blank. Make a best educated guess if you do not know the correct answer, but for the most part you would have seen these errors, if not yourself, then at least in the discussion forums you would have seen some of you asking these questions. So that's the spot the error problem. And the final one is to write a MATLAB code. This will be a relatively short MATLAB code. We know that you do not have access to MATLAB, so we are not expecting that we will copy paste and put it in MATLAB and see whether the code is correct or not. No, that's not what we are expecting. We are expecting 2 things. First one is whether your logic is correct. So for example, we have used Newton-Raphson. Your logic in doing this Newton-Raphson code is correct or not is one thing we will check. The second thing we will check is that there are no obvious errors with respect to implementing MATLAB. So for example, if you want to check if x is if you write if x equal to 5, that's not correct. You have to give if x equal to 5. 2 equal signs is a comparison operator. So that is something that you have learned in your MATLAB course. So those are simple things that we will check. But again, this problem will be graded manually. So what we are looking for is really whether the algorithm that you're using is correct or not. So that is about writing the code. It will be one question worth 15 marks and only for modules 5, 6, 7 and 8. That is going to be what is expected of you from this particular problem. For writing a code problem only, you will be asked to write a code which involves fundas from modules 5 or module 6 or module 7 or module 8. Rest of the problems will cover modules 1 through 8. Writing a code, this particular one only, will cover modules 5, 6, 7 or 8, the last 4 modules. Okay, so that is about the final exam. Let me check if we have any questions. No, there are no questions about final exam itself. No additional questions about final exam. So let's go on to the other set of questions. The next set of questions was, can you show a few more examples of user-defined functions? I'm not very sure what the person who asked the question meant by user-defined function. So if you can in the live chat, if you have a question, then you can ask that and I can answer that question. User-defined functions is a terminology that is used in simulation software such as FLUENT or Aspen or CFX and things like that, where externally people write a small snippet of the code that will talk to the main solver. I'm not aware of the term user-defined functions per se in MATLAB, or I'm not aware of the context in which this question is asked. So therefore, I am not very sure how I can answer this question. But with respect to if you're asking the questions about making applications in MATLAB, making applications in MATLAB is a little bit intermediate to advanced level topic, something that we have not covered so far. But what it really would involve is we have gone over how to write functions in MATLAB. The functions were written, for example, to pass on to fsolve, to pass on to ODE45, so on and so forth. Those functions typically that you use were 4 or 5 or 10 line functions. When it comes to more application development, this will be 500 lines, 1000 lines, 2000 line code. So we won't write them in one single function, but we'll break them in modular form, each function working towards a specific objective, and those things you would be able to combine together, and you can use certain tools in MATLAB, certain publishing tools in MATLAB to create this user-defined function type of a funda, or you can create a library type of a thing in MATLAB. So other than that, I'm not exactly sure what this question implies, but if you have a further follow-up question, you can ask in the forum, and I'll try to make a video and respond to that surely. Implementation of multi-step methods in MATLAB, I'll skip that that question for now. Multi-step methods, I believe this question was in the context of ODE solving. Multi-step methods are basically another class of methods. So the class of methods that we have covered in module 7 are what is known as Rangekutta family of methods. They're using the value yi and ti, we predict what is going to happen at yi plus 1. That's how the RK type of methods work. Multi-step methods actually say, so what we do in RK methods is we ignore the fact that we have y1, y2, y3, y4 up to yi. All this information we are ignoring, we are only using the information at yi. Multi-step method, on the other hand, use the past information as well. Those are a different class of methods, and an example of those methods are Adam-Bashford method and Adam-Moulton method. Those are examples of those methods. I can, yes, okay, I'll change the font size. Okay, so we are on this question. So the multi-step methods are of the type Adam-Bashford and Adam-Moulton methods. What I will do is I'll post a small 2-page PDF on the course website to talk about the multi-step method, and that will help answer this question. Next one is, the suggestion is to add an extra lecture in every module to use the concepts for practical examples. So yes, might be a little late in the day for me to add an extra lecture in each module, but let me go over the problems that you have solved in your assignments, and we will go over that. So in your first assignment, you have solved a salary problem, and the problem really over there was how to use this compound interest. So first module was a very introductory module for you guys. We were introducing you to MATLAB, so this was a reasonably easy problem in the sense it can be done by a calculator as well, the problem as it was formulated. So there are two people, one starts with 1 unit salary with a 6% compound interest, another starts with a 1.25 unit salary with a 2% compound interest, and how does the value keep changing year on year was this particular problem. The next practical problem was when it came to integration, and integration was the problem that you solved was given the incident solar power, how do you compute the net energy, and that was an integration problem. Integration is used quite a bit in several examples. For example, this is one class of example where integration is used a lot. Given a flux, how do you calculate the total amount of that quantity? Given the flux of energy, how do you calculate total energy? Given the flux of material flow, how do you calculate the total amount of flow, so on and so forth. Those are the problems that are calculated using single integral or multiple or double integral and so on. So that is one set of problems. The other set of problems were for differentiation, numerical differentiation. Given a velocity of fluid, how do you calculate gradient of that velocity? So when there is a fluid flowing over a flat plate, the velocity at the plate is 0, the velocity far away from the plate is equal to the free flowing velocity, and the velocity smoothly changes along this region, and we were to find the gradient of that velocity, and the gradient of that velocity was found using the numerical differentiation. The next problem was in linear algebra, and linear algebra is fairly versatile, so we actually just really touched the surface of the linear algebra, and that was to calculate the field composition based on the total cost. So you have n equations in n unknowns. In this particular example, you had 2 equations and 2 unknowns. There is a related question about what are the practical applications from industrial viewpoint. So linear algebra is used very frequently in model analysis type of work, in control systems analysis type of work, stability analysis in industry as well as in research. So linear algebra actually is really the reason for popularity of MATLAB. 35 years ago, when the MATLAB was first made, it was made by one professor to help his students with linear algebra. There is a linear algebra package in FORTRAN called LinPack, and it requires a lot of programming, and the professor wanted the students to really focus on the fundas of linear algebra rather than fundas of programming, and that's how MATLAB actually started, I think in 1970s. So if you go to MathWorks webpage, they have some history of how MATLAB started. So linear algebra is one of the strong points of MATLAB, and that's where you will see in the industry MATLAB being used quite a lot, where linear algebra gets used a lot. So for systems analysis, linear system analysis, for stability analysis, dynamical system analysis, analysis of control systems, analysis of control structures, for identifying the models, a little bit in time series analysis. There's a course by my colleague called Applied Time Series Analysis. In that, it gets used along with another programming language called R. That's where it gets used quite a lot. Coming to the other type of problems, in nonlinear equation solving, we took 2 examples. One example was to find gas volume using van der Waals equation of state. The ideal gas equation of state is a direct equation to find the volume. The van der Waals equation of state is a cubic equation to find the volume. So you have to use a solver such as fsolve or f0 to solve this kind of a problem. It is used quite a bit in property estimation and so on, in research, as well as a little bit in industry as well. And the other type of problem was to find the time at which a rocket attains a given velocity. So this type of a problems where the second problem is a little bit of a design problem. So the example of design problem from chemical engineering is this. So let's say we have a reactor. That reactor, let's say, is used to generate methanol, for example, and we want to generate, say, 100 tons of methanol. Okay, so we solve the simulation problem in order to find the input for input and output relationship. The design problem is to find out various parameters of the system so that it generates 100 tons of methanol. This type of a design problem is also used a little bit in the industry for relatively straightforward design problems. People use MATLAB quite a bit in the industry. And there is a related question which says MATLAB is a great tool with projects and research areas. I'd like to work with applied mathematics. The student works with pure math and with applied mathematics. And yes, indeed, so I have a couple of friends who are actually from mathematics background. What they were able to do was really use their math fundamentals in order to take a very fresh approach towards the problem solving compared to what engineers use in order to solve the problems using MATLAB. So you would have seen that MATLAB is an extremely applied tool. We bring in the fundamentals. What this course is intended to do is primarily to get you introduced to MATLAB, but you can actually combine that with fundamentals of numerical problem solving in order to understand this in a better way, and that is something that industry as well as research labs look for in the potential hirees. A good combination of applied skills as well as fundamental skills. That is something that is definitely valuable. And this particular thing that I talked about, design problems, is one more sort of challenging problem where MATLAB does get used quite a bit in the industry. The other set of problems that we solved were in regression and interpolation. So one of the problem was the temperature is changing with altitude, and to correlate the change in the temperature with the change in the altitude. This comes under the category of property estimation type of problems. MATLAB is used quite a bit in property estimation type of problems or correlation type of problems. So where you are trying to extract some kind of a model that will fit a data, MATLAB is used quite a bit. There are other tools as well that are used along with MATLAB or independent of MATLAB, but the statistical toolbox in MATLAB is something that is used for statistical analysis as well as for curve fitting. In module 6, we only gave an introduction to curve fitting, but people who are interested in statistics and interested in curve fitting type of problems, you use the fundas taught in module 6 to introduce yourself to the statistical toolbox in MATLAB for this. And the final set of problems that we are currently looking at in module 7 is the RL circuit example from electrical engineering, and water level in tank, which is a standard problem in process control that we teach in undergraduate. And solving ODEs is the other big fort of MATLAB. This is another place where I personally, for example, have used MATLAB quite a lot, both in research as well as in industry. And again, this is a skill that that becomes fairly useful when it comes to industry. Okay. So the next question was how to use Jacobian in MATLAB. Or sorry, not how to use Jacobian, sorry. What is the use of Jacobian? So one straightforward use of Jacobian that is there is, for example, in solving nonlinear equation. So the solving nonlinear, let me go to solving nonlinear equation. If you are solving nonlinear equations using the Newton-Raphson method, let's go to Newton-Raphson. Okay, so this was the Newton-Raphson method in single variable. Excuse me. Okay. So this was Newton-Raphson method in single variable. So this is f dash of x. This is basically df by dx. If you wanted to use Newton-Raphson method in multiple variable, this f dash of x gets replaced by the Jacobian, or more appropriately, the inverse of the Jacobian. So the Newton-Raphson's method in multiple variables becomes xi plus 1 equal to xi minus Jacobian inverse multiplied by f. So let me write this. Insert equation x of equal to x minus Jacobian inverse f of x. This is how you will calculate multivariable Newton-Raphson. Okay, so this is one place where Jacobian is used. Jacobian is another thing about the Jacobian is it is basically differentiation in multiple variables. So places where differentiation is used, Jacobian is also used in those places. For example, in order to find gradient of a scalar function, gradient of scalar function, people from mechanical, aerospace, and chemical engineering would have used gradient of a scalar function in their fluid mechanics type of problems, for example. That's an example where Jacobian gets used. Another example where Jacobian gets used is for solving optimization type of problems. Optimization was something that we haven't and will not cover in this particular course, but that is another place where Jacobian gets used. Jacobian is also used in something called sensitivity analysis. Sensitivity analysis is another thing that gets used in both in research and in industry quite a bit. So that's again another place where Jacobian gets used. So Jacobian is really derivative in multiple dimensions. You can think of it as a derivative in multiple dimensions. So places where derivatives get used, Jacobian gets used as well when it comes to multiple variables. And I think, yes, and the last question was, I think about probably about good practices. The question was that, for example, the factorial problem. So let's say we wanted to find n factorial. We can do it in two ways. Let's open MATLAB. Okay, so the factorial problem, we can do it in two ways. Let's say n equal to 5, fact val equal to 1 for I equal to 2 to n. Yes, I think the people here have told that the font size is too small, so let me just increase the font size. So sorry, that's not the one. Font size. Okay, so n equal to 5, fact val equal to 1 for I equal to 1 to n. Fact val is fact val into I end. Okay, so this was method 1. This is exactly what one of you have asked in your question. Method 2, fact val equal to prod 1 to n. Actually, I will use this as fact val 2 equal to prod 1 to n. Okay, you can run this and get the values. You can see fact val is 120, fact val 2 is also equal to 120. So the question that one of you has asked was that we have used both these methods, which method should you use? I think I'll answer this question in two parts. First part is use the method that you are most comfortable with. Okay, so there is no reason to use one method over the other if you are not comfortable with using that method. So that's the first part of the answer. The second part of the answer is this: I would strongly suggest that you practice a lot so that you use this particular method instead of this method. The reason is that the codes that you end up writing are very much readable once you do something like this. They are oftentimes easier to debug if you use some of the basic functionalities of MATLAB. And if you are going to use this particular part of the code, say 10,000 times in any kind of an iteration, then every 10 milliseconds that you save in this type of an operation means that that code overall will run faster. For example, if it runs for 10 milliseconds faster, and it runs faster and it does this iteration for 10,000 times, then you would have saved something of the order of 1000 milliseconds or 10 seconds in the simulation time, and those times sometimes get added up. This particular example actually, because MATLAB uses some kind of an accelerated way of solving problems, in these two methods will not see an improvement in the speed of calculation. However, the second method is a better programming practice as you become more and more used to programming in MATLAB. So this is something that I would recommend. Try to practice MATLAB enough so that you become comfortable using this powerful application ways of MATLAB. But the big answer over here is do what you are most comfortable with. The next question is about plotting a bicubic linear equation. I believe this comes from image processing viewpoint, I think. So I am not aware, or I mean, I have not done image processing myself. So this is something, unfortunately, I would not be able to answer. If you still have a question, you can please post it on the forum. I will try to find out the answer to that question and will respond to you. But this is something that we did not cover in this course. This is something that's outside my area of expertise, so I cannot give you an answer immediately on this one. And next question, how to solve inverse of a vector matrix with help of MATLAB, and how to get the determinant of a vector matrix. I'm not exactly sure what you mean by a vector matrix, but inverse of a vector doesn't exist in the vector the way we use in terms of MATLAB. Inverses exist for square matrices. There are pseudo inverse for non-square matrices, but inverses are defined for square matrices only. Inverses are computed using INV. That's the command that is used for computing inverse. It's possible I have misunderstood your question. So if you can elaborate on your question, sure, I'll be able to answer your question. How to compute a determinant? Let me see. Help det. Yeah. So det is the determinant of a matrix. I have not used determinant for a really long time, so that's why I couldn't answer that question immediately. But det is the way to compute determinant of a square matrix. Usually, for the most part, for the things that you need to use determinant, I would strongly suggest go back to your linear algebra books to find out a more efficient way of. There might be alternative ways to solve the same problem. But if not, to find the determinant of a matrix, you use the command det. Suppose in Newton-Raphson's method, I'm using numerical derivative. Is error under control? Okay, so in Newton-Raphson's method, usually for a lot of practical problems is actually fairly finicky method. In fact, fsolve I have elaborated in module 5. Fsolve doesn't use Newton-Raphson's itself. It uses an optimization based method that tries to minimize f square of x instead of finding f of x equal to 0. Newton-Raphson's method is very finicky. So small errors in computing f dash of x will cause some problems with Newton-Raphson's methods for a lot of practical problems. So for Newton-Raphson's method, if you know how to compute Jacobian or a derivative analytically, please use the analytical derivative. If you don't know how to calculate derivative analytically, then use the numerical derivative. In using the numerical derivative, please use the fundas about errors in derivatives that we have covered in module 3, first part of module 3. use the step sizes appropriately so that the errors in derivatives are minimized. So that is what I can tell you. So for Newton-Raphson's method, if analytical derivative is available, please use analytical derivative. So I'm not sure if this was exactly what your question was, but yeah, I mean this is so the error performance will be better for numerical for Newton-Raphson's method if you use analytical derivative. With computation of numerical derivative, the speed of conversions with respect to the number of function evaluation falls in Newton-Raphson's, and I have covered this in computational techniques course in the module on Newton-Raphson's method. Okay, the next question is Simpson's method faster than trapezoidal method? Simpson's method is more accurate than trapezoidal method. Integration is usually one-time solution. So when we talk about integration, as opposed to talking about ODE solving is a stepwise solving. You start with y0, you find y1. From y1 you find y2, from y2 you find y3, from y3 you find y4. That's how ODE solving works. Integration, we usually like to think of solving from integral from a to b f of x dx. So if you're thinking from that context, integral a to b f of x dx, Simpson's method is not faster or slower than trapezoidal method. Simpson's 1/3 rule is more accurate than trapezoidal rule, and we have seen an example of that in module 3, I believe lecture 3.5 probably. We have seen an example how the error works differently for trapezoidal versus Simpson's 1/3 rule. So Simpson's 1/3 rule is more accurate than trapezoidal rule, and we have demonstrated that in module 3.5, lecture 3.5, I believe. Why are ODEs solved only numerically with MATLAB? Why can't they be solved analytically? Actually, they can be solved analytically also using this symbolic toolbox of MATLAB. Symbolic toolbox is something beyond the scope of this course. Therefore, I did not cover how to solve ODEs analytically using symbolic toolbox. ODEs, so not exactly ODEs can be solved using symbolic toolbox. You kind of have to play a trick in order to solve ODEs using symbolic toolbox. But yes, they can be solved for a very small subset of ODEs. They can be solved analytically. The ODE solving technique, numerical techniques that we talked about in this course are more versatile. We did not put any restriction on how the function my ODE fun would be. Okay, so we solved a few different problems for my ODE fun, but module 7 covers solving ODEs in a single variable. Module 8 covers solving multiple ODEs in multiple variables where all the ODEs are coupled with each other. So numerical method that you will see in module 8 is very versatile in the sense that what you do in module 7 for a single scalar, you just apply it to a vector in module 8 and you are all done. So that's the power of using numerical methods. So therefore, we covered numerical techniques to solve ODEs. So yes, there are a few analytical techniques to solve integration problems and some other set of problems also, something we have not covered in this course. Bit error analysis for wireless communication. I'm sorry, this is beyond my background. So the question was about bit error analysis for wireless communication in the context of Rickian fading channel and Rayleigh fading channel. So I'm sorry, I do not have the background to answer this question. So I do not know the answer to that question at all. So my background is from chemical engineering. So I'm sorry, I'm not able to answer that question. So let's see, we have a few more minutes, and if you have further questions, do let me know. With respect to a couple of questions that have been asked by G. Jyotish, if we can take this offline, you can write on the forum itself, and I'll try to find out if there are persons who can help you with answering these questions. Could it be better to fit a curve and then solve it analytically than numerically? That's actually a very good question from Ginger, and I'm not sure in what context he has asked or she has asked this question, but let me answer this question in multiple contexts. So let's say we have a bunch of data. So let me just pick up one of the lectures from regression. Let me just pick this up. Okay. So we have this particular data, and let's say we wanted to find area under this particular curve. Okay, so in module 3, the way we found that area under this particular curve was using trapezoidal rule or Simpson's 1/3 rule. But in trapezoidal rule or Simpson's 1/3 rule, it works very nicely if the data is equally spaced, one, or when there are the data does not have a lot of noise associated with it. But if the data is extremely noisy, then a better approach to integrate or differentiate the data would be to fit a curve and differentiate that curve. So using regression, using polynomial regression, let me see if there is polynomial regression. I'm not sure if we covered polynomial regression or not. Yeah, we did not cover polynomial regression, probably. But what is done with this type of data a lot is, instead of fitting a first order curve to this data, what you will do is you will fit, let's say, a cubic or a fourth order curve to this data. So the curve that you will fit is a plus bx plus cx square plus dx cube plus ex to the power 4. You will fit that curve, you will get the values of a, b, c, d and e, and let's say you wanted to find the differentiation of d by dx of this particular thing, and the d by dx is going to be b plus 2cx plus 3cx 3dx square plus 4ex to the power 3. So that is something that is done in differentiation if it is highly noisy data, in integration if it is highly noisy data. In case of some other type of problems, ODE solving problems, where the boundary or initial conditions are given in terms of data, you might fit a curve to that data and do this. This is something we did not cover in this course because it's more of an advanced application topic rather than a numerical topic itself. But that is a wonderful question itself. Okay, so yes, are there any other questions? Let me see if I have missed any questions before. Okay, so yeah, if there are no other questions, I think we can call an end to this session. So I hope the session was useful to you and we were able to answer some of your questions. If you have further questions, please feel free to ask them on the forum. And even if it's outside the scope of this course, that should not be a problem. I may not be able to answer some of your questions, but if not, I'll try to find out who the appropriate person might be who might be able to answer your questions. So with that, we come to the end of the session, and thank you for listening in.